Well, hi, good morning, and thanks so much for joining me here in my shop. It's March 12th. We're getting close to the Ides of March. And I'm going to continue with this radio. I'm pretty sure I'm going to nail the problem with the 1 week or dead channel today. I'm really close. I got to be really close after yesterday. But before I do that, I just want to take a moment to talk to you about propaganda. Propaganda is something that these shortwave radios used to deliver in the past and the like, and I just want to talk a little bit about how it works at a very general level. So the basic principle is this: people cannot be manipulated with the truth. If someone offers you the truth, they probably have no intention of manipulating you. In fact, they're trying to help you with the truth. When people deliver the truth, they usually do it without emotion. Now, if you're interested in manipulating people, you can't use the truth. So, if you're really into this manipulation thing, the first thing you have to do is kill the sources of truth and then replace them with your manipulative lie. So if we think about killing sources of truth, you might hear people talk about the mainstream media, which of course is a label that's utilized, that's part of the manipulation right there. There is no mainstream media. I would say there's a standard media. Standard, like a news media. You can recognize a standard news media because they use professional journalists and they have written standards that they use in delivering the news. And all standard news deliverers tell pretty much the same story because they're all doing their best to dig up the truth. That's what they're proud about. Well, if you listen to the standard news, and what am I talking about? ABC, NBC, CBS, CBC in Canada, actually CTV too, and the other news media in Canada, BBC, and I don't know what else they have in Britain. In the United States, it's NPR and Voice of America. Now, Voice of America really stands out, by the way. As far as I know, Voice of America is the only news service in the world that is required by law to present the truth. Of course, nobody in the United States or here in Canada is listening to Voice of America, but it is available on the internet. They're required by law, to be honest. You'd find all those news services tell pretty much the same story. Now, I can think of some other news services in their evening shows. I won't name them. It's an American network I'm thinking of. You can probably guess who I'm talking about. That deliver a different story from the standard news. And when they do it, they deliver it with emotion. Why? Why? And I'm not talking so much about their news program, but their evening programs where they have people allowed to come out and say things which don't jive with the standard news, which they demean by calling it the mainstream news, give it that nickname. You can pick this stuff up really easily when you're listening. I mean, you can figure it out really easily. You can sense when someone's manipulating you because they speak with emotion. I hope there's no emotion in my voice right now. Maybe there is because I'm very upset about this. Very, very upset about this. But when you watch a professional news broadcast, like a BBC or CBC or any one of those other ones I listed, the news presenter presents it with no emotion, or very, very, very little emotion. They're just reading you the facts. So you can keep all that in mind when you're listening to people talk and wondering what the truth is. Because we have a war in the world, a big war in the world now, and they always say, the first thing to get killed during war is the truth, and that's true. That's the truth. So everything we hear now, we have to understand that it's being presented to us in the midst of a war, and there's lots of attempts to manipulate us, so we'll either do something or not do something, rather than just absorb the truth and decide for ourselves what we should or shouldn't do. So that's my little speech for this morning. I try to stay away from this kind of stuff on my channel because I understand I'm in my shop to escape all this, and you're probably watching this video to escape all this. So I'm trying not to be too specific about any particular event, but to give you some kind of general view of things, a view I've developed or I've come to believe about how these things work. I've been listening to shortwave radio since I was a kid. The word propaganda was kicked around all the time when I was a kid. I used to listen to Radio Moscow a lot when I was a kid. BBC, all the different news services. So it's been on my mind all my life. Manipulation through the dissemination of false information. Okay, let's get this shortwave radio going here. Actually, it's going to be a little while before the shortwave side of this is working right. Let's get busy on this radio. So, yesterday I ended right at what could be called the 2 audio preamp tubes. I got a little confused about the B plus on one of the tubes, but I sorted that out. So we're going to start right there now. I'm going to check the output side of these 2 tubes and see if it doesn't match. And the way I'm going to do this is I'm not going to put in a audio type, program type material like I was doing yesterday. So there won't be voices coming out here. Instead, I'm going to use a signal generator. It's this one right up here. I'll probably flip this onto mono because I know now it's not really a factor. It'll just end up sending the same signal down both channels. And then we're going to look at both channels at once. I'm going to try to do that. We're going to use my oscilloscope up here, so we can compare the two in terms of signal level and things like that. So my first goal is to get the output of the 2 audio preamp tubes at the plate side onto my oscilloscope with a controllable signal going into the audio input, the phono input on the receiver, and we'll go from there. We'll see how this works out. That's just getting that going is challenging enough. So I'm going to stop now, calm myself down a little bit because I am upset, and get focused on the radio, which will help me. I'm going to use this radio to calm myself down. That's pretty funny. Okay, let's take a look at what I've got set up. The radio's not switched on yet, so I do have this signal generator running. I believe it's running, I don't know if you can see that number, at 4 kilohertz. It's a little bit of an ear-piercing frequency, but we can start there, change it later. I've got my oscilloscope running. You can see it there. And you can also see another camera looking right into it, so we can get a close look in case we need a close look. The 2 scope leads coming from the oscilloscope are identical leads. They're currently connected to the 2 plate resistors, 2 independent plate resistors that are here for each of these 2 tubes. That's the 220K resistors, where I measured the 60 volts when I finally did it properly. So the output of these 2 audio tubes should be identical, should show up on the scope. My concern here always is I set this stuff up, I don't quite get it right, I see results and start interpreting the results when really there's something wrong with what I've done. I don't think that's the case yet. I don't know, I haven't turned it on. First thing I need to do is renormalize the input so it's of a similar level to yesterday, just by changing the output strength of the signal generator, listening on the speakers, and just getting it to a similar level. So that part is similar. Then we can pay better attention to what's going on the oscilloscope. There's a chance I've connected one of these leads in the wrong spot, same way I did the incorrect B plus voltage. So we'll sort that out, easy enough. You can look down in there and you can see that I've simply clipped onto the ends of a couple of identical value resistors. That's red, yellow, 220K, 1 waters, exactly what's on the schematic. There's no doubt those are the correct ones. I have the speakers connected. I've reversed the speakers. When I'm connecting them, I'm not being careful, and sometimes what was left becomes right. I guess what was left becomes right. I guess that's the way it would be. I do have a stereo microphone operating in here, so you can pick this up if you're listening, especially if you're listening with headphones or your speakers are divided. So you might say, hey, wait a minute, how come the right channel's louder now? Well, it's probably just because I reconnected the speakers differently and I'm just not paying attention to that. So we need to turn on the receiver. Oh, I've also switched off the stereo button down here, so it's mono. This is only have a single source here. I'm feeding it right into the phono, same as I was doing yesterday essentially, but just one side. But with the mono switch to mono stereo switch to mono, and having gone through the schematic and all that stuff yesterday, I'm very comfortable that that should not be a problem at all. Not a change of any significance. All signals should travel through until somewhere around where I'm doing my testing now. At least that's the impression I'm operating under, that I'm really close. Just no cigar yet. Okay, we're going to switch this on, volume down. Just one last look to make sure I haven't done something foolish. I do have a couple of grounds going at the ground connections from equipment going at the radio, but they're all chassis grounded, so there's no issue there. Nothing touching the hot tubes. We're good to go. Oh, I picked something here. Pick phono. Why don't we start with broadcast, just to make sure it's still doing what it always did. One channel working, the other one not. And I understand the balance control now. Got that all sorted out, so we know balance is somewhere like that. We also know the balance control does not totally cut out one channel, just reduces one channel a bit. Actually, it's a volume cut on one channel or the other. If you have it in the middle, they're like this. Cut is too strong a word. It's a volume reducer. Okay, I think my head is clear. I'm already drinking coffee at this point, so I think we're good to go now. We'll go phono. No, we'll go broadcast. Power on. We're cooking. Notice the scope just went right off. It's because I've got this on DC, but I don't want it on DC. I want both channels switched on. This one goes flying by. Got these are not balanced. Let's set this to 0.1, and we'll set this to also 0.1. And now we'll just move both up like that. So that's one of them, and that's the other of them. Quite see it in this bit of a distant shot, so let's just take a closer look. These scope terminals have color codes on them. You see there's a red one and a blue one, so we know which is which, because the same colors appear down on the business end of the scope lead. We see nothing there, but the volume is turned down. We hear nothing. The volume is turned down. We're on broadcast. Here we go. Well, wait a minute. Let's get the long shot here, because you can see the scope in the background probably well enough. Get this handy dandy swing it out of the way system. Isn't that something? No, not really. Okay. We're on partial power, so we'll go full power. Just realized this radio I think has screw-in miniature lights, and I am really at a loss for screw-in miniature lights. I've got all kinds of bayonet, but we have some trouble replacing that one burned out light. Okay, I hear a little bit of a hum. Here we go. Let's turn it up. Okay, so I hear the sound coming out of this speaker up here. We'll do the balance thing. Down. Knockdown. So we know that the dead channel is the one off to my right. We don't know which one of these is dead. Oh, I see something has happened on the scope already. Now, let's take a look. Don't want to interpret this, but one is showing a hum with some noise on it. Let's see if I can just get my camera just a little bit. I think I had it up like this when I focused it. You can see there's a hum, and then you can see there's some hashy noise in there, just a little bit. Yeah, if I turn it up. There we are, that's pretty clear. So we're already getting indications that one channel working, one channel not, but we don't know yet that I've hooked up the oscilloscope leads properly. Well, I'm speaking to you from the future now. I was putting together the video you're watching. When I finished my session today, I had 2 hours of video, and a large portion of it was me trying to unconfuse myself. So rather than show you all of that, I'm going to skip ahead now. If I didn't say anything, you probably wouldn't even be aware. But I did an awful lot of testing and proving out of all the components all around these two tubes here. See, this one's up on an extender now. So there may be some questions. Gee, you should check this. Gee, you should check that. Chances are I did check those things. Like for instance, the grid leak resistors and other aspects of it. So rather than show you all that, because of the confusions, I get confused about which tube is which, and other kinds of silly stuff happens. I'm just going to skip ahead to where I'm continuing with the work. I promise you at the end of this video, I promise you what? I promise you that I'm going to be showing you an impossible situation, which of course is impossible. But that's where I end up with this today. So thanks for watching to this point, and keep on watching. Okay, so I think I've attached my scope leads to the tube pin side of those two resistors. So we're looking at what is on the grids of those resistors. Now, interesting enough, they're really big resistors, 10 megohm resistors, and my test leads are in that range of 10 megohms. So they're both set to times 10. I think that makes them 10 megohms. I'm not sure. Input to my scope is 1 megohm. So I'm pretty sure times 10's got to be 9, whatever the ratio is. So that should bleed the signal down a bit, but it would be doing both, the same to both channels. Okay, let's switch on the set here. I'll get this out right there. Switch on the set. See what's going on. We'll verify the situation. I've got the red lead on the, oh, I got them backwards. I've got the red lead, shoot. Well, I'm going to switch them up here. This is going to add to the confusion if I'm not careful. So I believe I've got the suspect resistor. No, that's right. The suspect resistor, the funny stuff is going on the upper display. Let me put it back. I know which is which. Just trying to make it consistent on the scope. I just stick my camera back up there for whatever it's worth. So this is me just kind of backtracking to ensure or find out what's going on these resistors up above, because I've never tested them up above. I tested these terminals that are down there. If I did test them up above, I don't remember. Don't remember. Okay, we're good to go. Everybody happy? Here we go. This guy's out of the picture. Signal generator still running like it was. Okay, everything's good. Give it all that Niagara Falls has got. I hear the tone. So we're expecting to see this on the scope. Let's check a little bit of volume here. And balance. Gone on one side. Still, we've got the same thing. Now we look upon the oscilloscope. I'm going to switch cameras here. Everything's out of focus and the like. So just bear with me a moment. I'll quickly refocus this camera. Away. Oop. Essentially, I'm trying to bring everything into focus. Okay, both set to 10. This one's lacking. Now, let me make go a little bit more. I think both signals are there. Let me move the balance. One gone, other gone. Is that lower one bigger than the upper one? The lower, it's not quite focused, is that? Let me do this. Maybe I can bring it into better focus. Come on, camera. Well, that's kind of interesting. The one that's louder has a less signal here. The signal's there. So that's on the blue. And the blue is on the other resistor. I must have, maybe I get things turned around? No, that never happens to me. What more can we do here? Crank up the input or the volume. Get a better look at this. My scope to trigger. It's triggering on 60 cycles there. You put on the low frequency reject. No, it's really triggering on it. Funny. Okay, we're triggering on the frequency you're listening to. Balance. Well, that seems to be saying something funny. We have lots of signal on the quiet channel. By the way, what you're hearing all the time, the tone is always coming out of one speaker. Just to be, well, you know what, there is a little bit coming out of the other speaker. Just gotta move my head around in here. Jeepers. Creepers. Okay, turn it down a bit. We get them the same. So that looks to be about the same level. I'm trying to use my ears now to hear the balance. Sounds like it's balanced. Sounds like there's a balanced output. I don't have the mono switch on. Oh, for crying out loud. No, that's stereo. That's a stereo switch. Okay, that's good. That's good. That's mono. ×1 setting. I'm going to listen to it drain out some signal here. ×1. Back to ×10. That was the blue probe, the lower probe, now the upper probe. Doesn't make any difference. So we're going to go ×1. Give a little more juice here. What happened to the upper signal? Where'd it go? Where'd you go, man? It's the red one. Contact. There. Back on the red one. Just probably a bad scope lead contact. Okay, so let me disconnect one speaker here. Okay, one speaker, didn't hear any change. Go one side. On the other side. It's the weak channel. You know what's going on here. I'm losing my mind is what's going on. Okay, now we'll cut the louder speaker off. Balance control. There's 0 coming out of that speaker. Let me test the speaker now. Am I crazy? There it is. So that's back to the channel we can hear. The speakers are identical, but this one sounds a little quieter. That's not helping either. The speaker's working. Let me put it back on the channel of nothing. That's on the other channel now. It's absolutely nothing. Absolutely nothing. There certainly is stuff on the grid, according to this test, of both those tubes. The one we're not hearing, the tube we are not hearing. I just got to make that absolutely sure of this. Okay, looking up both speakers, but we're only hearing the one on the left. So let me do the balance. So the one, it must be this. We're here. We never hear this. We hear this. That's the upper. That's the red. Yeah, that's the resistor I've been, yeah, okay. Solve that confusion. We're back to the tube I tried changing yesterday with a replacement. It didn't seem to do anything. Let's flip this the other way. Okay, so now we're listening. Let me take this off. Okay, now we're listening to the channel that's going through the tube in question. There appears to be a signal right on the grid. Right? Because there's a signal on both grids. It's a signal on the grid. But for crying out loud, it doesn't come out of the speaker. On the other side of this tube, there's no signal. We must change this tube again. Okay, so I'm going to pull it out with the set on. I'm going to burn my fingers doing it. Nope. Maybe. Well, it's a small burn at this point. Okay, the tube is out. Wasn't watching the scope. Did anything happen there? Now we're going to put in the alternate tube. It's going in. Tube is in. Heater's on. Do we hear anything? What are the chances we have two similarly defective tubes? The chance is nil. The chance is nil. We have a tube socket. We're down to the tube socket. Well, that's interesting. If I pull that tube out or put the tube extender in there, we can just pull the tube out and look for this signal in pin number 2. Let me just double check that, make sure I'm actually on the ball here. EBC 81 is the tube that we're fooling with. EBC 81 and the pin 9. I may have made a mistake there. No, I'm looking at the wrong spot. Totally wrong spot. Totally wrong. Pin number 2. Pin number 2 is the grid to the EABC 81. And the tube I pulled out. Looks like an 80. What am I doing here? 80. That should be an 80. Okay, I got a little more turnaround here. I gotta stop for a minute. I have exhausted my brain power. Sometimes I get caught up in the idea that, you know, when you see it on the schematic, this one's higher, this one's lower on the schematic. I start thinking it's that way in the radio. The tube I replaced. Yeah, I gotta stop here. I'm just spinning around in circles. Yeah, I know when I've been in here too long, when I start just getting everything all turned around, which is what's happening. So, to prove which tube is doing the work, I'm going to pull one of them out and see if the sound disappears. Okay, trying not to burn my fingers. This guy's doing the work. I'm focused on this tube because I've gotten confused. Ooh, that was a little scary. It's the other tube that's not producing. That's got the blue. Both tubes getting a grid circuit. Okay, so I've been on the wrong tube here. The blue. What's going on with the other tube? Why are you not doing the job? The other tube is a new tube. Okay. Now, interestingly enough, the resistor that I'm hooked up to, so look at the blue signal, which is this one here, isn't it? Did I reverse these? I didn't reverse these, did I? No, thank God. Oh my God. That resistor has a hole in the end of it. You probably saw it in one of the camera shots. I think, you know what, I'm not on the tube terminal end of that resistor. In fact, neither of these resistors, the scope leads are on the input end, not the output end. Let's change that. Okay, so we're going to take this off. Let me just turn this down in case there's a surprise. This is a tough one to get on and off. Come on, there we go. He's off. I'm going to put him on the other end. This is the end that I believe is hooked right up to the tube. Hey. Okay, don't jump to conclusions. We'll do the same with the other one. Okay, try and get it off here. The getting burned or electrocuted. It's off. I'll try to put it on the other end. Oh my gosh, how am I going to do this? Whoa, I'll just drop it in there, Jim. It's very healthy to talk to yourself as if you're in the third person. It's very healthy, apparently. I just feel the heat just pouring off these tubes here, just waiting to burn my knuckle. I can't do it. Cannot get there. Turn the power off. Pull that big tube out of there. Don't dare touch this. Put on the test lead. I don't even need the output tubes in, but pretty sure. So I was actually testing, believe it or not, the wrong pin. I was doing those resistance tests back from this tube. I was on the wrong tube. I think, I don't know anything anymore. I know nothing. Okay, I just about grabbed that tube, which might be a big mistake. The other day we were cooking in the oven. I had basically a cast iron pan in the oven. Pulled the pan out, stuck it on top of the stove using my glove. And then a few minutes later I wanted to move the pan a little bit on the stove. I grabbed a handle. You've never seen somebody jump so fast. The solution to that is to get your hand in cold water. So I'm in the kitchen, so I just poured on the cold water. And I did not get any kind of injury. But man, if I just held that handle for a fraction of a second longer, goodness knows I would have had blisters all over my hand. See, I'm not just confused here. if there's more than one, I'm bound to get confused. Okay, so I have the scope leads now on the other side of the two resistors, which I believe are tied right to the pins. So we're really looking at the signal. I think. That's all I can say at this point. I think I got it right this time. Okay, let the set warm up. These are both switched to ×10. We see nothing at all in terms of the signal. What have you done? So I'm on the grounded in now, for sure. That's why there's nothing there. That means I was on the right end before. Oh my gosh. So what I'm going to do is I'm going to try sticking a tube extender in on the tube now in question and try to test using the tube extender, which is right here. Now that tube's probably gotten quite warm too. Let me take these scope leads out of here. Yeah, this is all an iterative process. It's just how you have to iterate the iterations. How hot is it? Oh, it's not very hot at all. Well, that's kind of weird. It's warm. EBC 81. How's that add up with the whole deal here? So that is the correct tube in the correct spot. Thank God for that. This is a brand new tube. Didn't I give this guy a test? It says Pope on it. Does that mean it's made in Holland? Pope. I think this is like an NOS tube from years and years and years ago, just never ever used. Okay. Tube, you can stick with the plan. I was going to change the plan. Stick with the plan. Tube extender in. Tube back in. This will give me access to all the tube terminals up above here. The EBC 81. EBC 81. Wait for that tube. Oh, it's so easy to look at the wrong. EBC 81, and the grid is on the other page. Grid is 2 on this one. Right, because I thought I had it wrong before. We're going to put this right on if I can. This is the blue. This is the bottom one. I'm going to have to look at one of them, I think. Can you fit on there? It's definitely 2. Fortunately, these things are numbered. Can't go too far wrong. Get in there. There we go. Okay, so we're on 2. With the blue. Blue is a lower 1, lower 2, blue, 2, blue, lower 1. I only have one scope lead connected. This one. Okay, power on again. We pulled this tube out and the set went dead. This is the tube that's not passing, appears to not be passing any signal. We are observing the grid. Okay, this is on times 1. Blue on AC. Balance control. See, the signal came up and the sound went down. The signal is definitely on the grid of this tube. It's the other tube we're listening to. They don't dare stop at this point. I'll lose track of it all. Okay, so we can now look for the plate up here. I can look at the plate. The plate on the EBC81. The plate is pin number 1, right beside pin number 2. Look upon the plate. That's where there should be 60 volts. Look upon the plate. Okay, so I'm going to move this off of here. I'm going to try anyway. I just don't want to accidentally touch something unexpectedly. It's a big safety rule not to do what I'm doing right now, which is attach and disconnect equipment to a live radio. Because of stuff like that. Because of exactly that kind of thing. Okay, we're going on pin number 1. Get under there. Over here. Oh. Maybe jump. Sounds like we discharged something. Okay, what is that? So there should be a large DC voltage here. Well, 60 volts. So we're going to put this on. This is on the times 1 scale probe, so we'll put this on 5. So that would be 60 volts divided by 5, 12. 12 divisions, that's too much. So we're going to put this on times 10. And then we'll put this on 1. That's 10 volts per division on this line. So we'll flip this to DC. Does it go 6 divisions? Ooh, 6 divisions. 1, 2, 3, 4, 5. Right up to the top. Let's move it down. 6 divisions. 1, 2, 3, 4, 5, 6. Right where that line is. Let's get that line out of there. Do that. Went the other way. No, it went right off the screen. Went right off the screen. 1 volt. 5 volts. Okay, let's figure this out. Times 5 is 50 volts per division. So we're not even getting that huge plate voltage again. Come on. Okay, so just calm down now. 5 volts per division times 10 on the probe. 50 volts per division. So this should just jump up 1. Bah! So it's going 100, 50, 65, 70. 170. Come on. Oh, yeah. Ow. I don't. Kumbaya. Kumbaya, my lord. Kumbaya. Gotta calm myself down here. Okay. So I'm definitely in the danger zone now. Rash behavior is possible. So I strain myself emotionally here. Okay, we're gonna read it with this meter. As a double check. Okay. Singing Kumbaya in here, holy smokes. Pin number 1. The belief is pin number 1 is the plate. It's not 1. What did I look at? I'm looking at the wrong tube again. I'm looking at the wrong tube. These diagrams on this page, I can't see it because of all the light. There are two tubes located right here. On this page, there are two tubes located right here. So I keep looking at the wrong one. We are looking at the EBC81. Pin 1 for the plate. Pin 1 for the plate. Pin 1. Definitely 1. I see the number 1. 166. Wow, am I ever going around in circles? It's supposed to be 60 volts there. We're back to the idea that this tube is not conducting anything. And therefore there's no voltage drop in the plate resistor. And the result is it's all showing up and sitting on the plate. Right back to an earlier theory. It's just a triode with some diodes. There's no screen in there to cause complications. I must test the tube. I'm sure I tested this tube. You gotta test it again. You gotta do it again. Okay, we're gonna test the triode portion, which is the part of the tube that we're concerned about. So 6.3 EV2103. 6.3 EV2103. 0 out here, and 15 and 48. 15 and 48. Turn it on this time. Stick it in. Pretty sure I tested this. Brand new tube just purchased. Okay, we're going to give it just a moment more. Such anxiety here. Any shorts in it? We see the short light flashing, which is an indication that it's probably good. 3000 scale. The throw it away number on here is 695. 700. 700 is about here. Throw it away. It doesn't go above there. Push the button. It's way above. There's nothing wrong with the tube. Holy smokes. What about the other idea that something's going on with the other circuitry that's using this tube, because there's two diodes in there, and somehow that is zapping the life out of this tube. And I don't know. So we want to try 0603, all zeros beyond that. 0603, all zeros beyond that. It strikes me I'm supposed to have this on English when I do the diode test. Press P1. That's better, yeah. I think this has to be on English to do this properly. So we're up above the diodes, okay. I may have made a mistake doing some earlier testing, but that's why I'm so slow to toss one of these out. We changed the 6 to an 8. It sounds familiar to me. We changed the 6 to an 8. Push that same button. Both diodes test okay. But my theory is there's something wrong with the circuit involving those diodes. How could that so the theory here is no current flowing through the tube. The cathode's disconnected. Cathode disconnected. Cathode disconnected. I'll say that one more time. All the wrong sheets. Cathode disconnected. So this is the EBC81. DC 81. So looking very carefully at this difficult to look at diagram, cathode goes right to ground. Pin 3. Oh my god, yeah, pin 3. Pin 3 is the cathode, right to ground. Pin 3 is the cathode. I'm on the ground. Pin 3 goes to ground. Pin 3, it goes to hard to ground. I mean, it's just a wire to ground. Put this on resistance. Get it into view. Pin 3. 1, 2, 3. Right to ground. Cathode can't be not connected. It's just a grounded cathode. There's no funny bias on the grid driving it into cutoff. Yeah, down here. Look. Jim. Look at the right tube. Cathode is tied to one side. Well, they're just using the ground, the same ground for the heater here. Just on the schematic, anyway. Pin 3 for sure. Really at a loss. How could you possibly get this 100 and something or other volts here on pin number 1, which we saw? I mean, we saw it on the scope, we saw it on the meter, we saw it yesterday. I got all excited, and later I decided it wasn't there. Why would I decide it wasn't there? Because I got the two tubes confused. That's probably what happened. I ended up testing the same tube twice. So the feed to the plate, how does it get higher? Like it's up at this voltage, the supply voltage. Close to the supply voltage, which would be dropped by the first resistor, caused by current flow from the other tube. So at this point, you'd have, I don't know, take a guess. That's 100K, it's in series with a 220K. Series here with the 220K. That's really mysterious. Is this a mistake? It's not 60? I can't imagine that's a mistake. Maybe they wrote something wrong. How can you possibly do it? Where would it come from? The only thing I've changed in this radio or capacitor is if I made a mistake, that's not going to allow voltage anywhere unless I installed a shorted capacitor in the wrong place. That's just so fat chance situation there. So this is connected here, and there's a capacitor which I would have replaced here. Where's it heading? It's heading over to a grid over here, so it's not going to find any. Yeah, you'd have to have a shorted capacitor and then some problem over here, which is picking up this high voltage. That can't happen. Yeah, it'd be a huge voltage on here. That would not be so good for the output tube. Big positive voltage on the grid here. It just can't be. Checked all the tube resistances on the resistance chart. They're all winners. Even this one. My head is a spinning. So the signal's on the grid. Both grids getting basically the same signal. So if you put, just putting a higher voltage on the plate shouldn't really shut down the tube, should it? You'd think that would just get it more exciting. The tube would conduct more. Like it would still work. You'd want more negative bias to compensate. Oh my gosh. What is going on here? So I probably need to track the voltage from across here and then across to here. Done that. That's where I found the high voltage and went wild. Then later I checked it on the tube plate. I probably checked it on this one, thinking I was doing this because I'm getting all turned around. That's probably what happened there. The tube with a runaway plate voltage coming from who knows where. That's my answer. The answer is it's time to stop. It's oh my gosh, it's 12:30. I got hours of video here. Well, it's a mystery. It's a complete, total mystery. And that's where it's going to have to stay for now. Because I'm done for today. Wow. Okay. Well, thanks a lot for watching. I'm not sure how I've edited this. And the whole thing is the whole thing. This might be like a 2.5-hour video. It ends nowhere. Thank you very much for watching. Get my head together and take a run at this again tomorrow.